The National Electrical Code, or NEC, does not provide a specific number for non-keyed porcelain ceiling lamp holders on a 20 amps 120 volt circuit. However, by following NEC guidelines for lighting load calculations, we can determine a reasonable maximum. The calculation typically assumes a 100 watt incandescent lamp for each holder. Based on this, a 20 amps 120 volt circuit can accommodate approximately 108 ceiling lamp holders. This number is derived from the total wattage the circuit can handle. A 20 amp circuit at 120 volts provides 2400 volt amps, which is calculated by multiplying 20 amps by 120 volts. With each lamp holder assumed to use 100 watts, dividing the total circuit capacity of 2400 watts by 100 watts per lamp holder results in 24 lamp holders, but this calculation is based on the maximum amount of amps in the circuit. The number that would be considered a standard amount is 80% of the total, which would then allow 108 lamps. It is important to consider that using lamps with higher wattage will reduce the number of lamp holders that can be safely installed. For example, if 150 watt lamps are used, the number of lamp holders must be reduced to maintain a safe load. It is always best practice to stay within 80% of the circuit's capacity to avoid overloading and potential hazards. The NEC does specify the maximum number of 20 amps 120 volts duplex receptacles allowed on a 20 amps 120 volt circuit. According to Article 210.19 of the NEC, a maximum of 11 duplex receptacles can be installed on such a circuit. This limit is based on the assumption that each duplex receptacle will handle a maximum load of 1800 watts. This wattage is derived from a 15 amps load at 120 volts, calculated as 15 amps multiplied by 120 volts. However, this calculation is typically used for general-purpose circuits where the actual load is unknown. If it is known that higher wattage loads will be connected to the receptacles, the number of receptacles must be reduced accordingly. For example, if the receptacles will be used to power appliances that draw a significant amount of power, such as heaters or power tools, fewer receptacles should be installed on the circuit. The key factor in determining the number of receptacles is the total load on the circuit. The circuit should not be loaded to more than 80% of its capacity, which in this case is 16 amps or 1920 watts. It is important to note that these calculations are based on specific assumptions and guidelines provided by the NEC. Local codes and regulations may vary, so it is always recommended to consult with a qualified electrician or local electrical inspector to ensure compliance with all applicable codes and regulations. Additionally, it is important to consider the specific application and usage of the circuit when determining the number of lamp holders or receptacles to install. Overloading a circuit can lead to overheating, electrical fires, and other hazards. Therefore, it is always better to err on the side of caution and install fewer devices than the maximum allowed by code. In summary, while the NEC does not provide a specific number for non-keyed porcelain ceiling lamp holders, a safe estimate based on typical lighting loads is approximately 108 holders, assuming 100 watt lamps. For duplex receptacles, the NEC specifies a maximum of 11 on a 20 amps 120 volt circuit. However, both of these numbers may need to be reduced depending on the actual load and usage of the circuit. Always consult with a qualified electrician and follow all applicable codes and regulations to ensure electrical safety. For the calculation of ceiling lamp holders, the critical factor is the total wattage of the lamps used. A 20 amps 120 volt circuit has a total capacity of 2400 volt amps, but for continuous loads, it is recommended to limit the load to 80% of the circuit's capacity. This means that the maximum continuous load on a 20 amp circuit should not exceed 16 amps or 1920 watts. To determine the number of lamp holders, divide the maximum continuous load by the wattage of each lamp. For example, if using 75 watt lamps, divide 1920 watts by 75 watts to get approximately 25 lamp holders. However, if using 60 watt lamps, divide 1920 watts by 60 watts to get approximately 32 lamp holders. It is also important to consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a long circuit is lower than the voltage at the beginning. This can cause lights to dim and appliances to function improperly. To minimize voltage drop, use larger gauge wires and keep circuit lengths as short as possible. The NEC provides guidelines for voltage drop in Article 210.19a on FBN number 4, which recommends that the voltage drop should not exceed 3% for branch circuits and 5% for feeders plus branch circuits. When calculating the number of receptacles on a 20 amps 120 volt circuit, the NEC uses a different approach. Instead of specifying a maximum number of receptacles, the NEC requires that the load in the circuit be calculated based on the actual usage of the receptacles. For general-purpose receptacle circuits in dwelling units, the NEC requires that a load of 180 volt amps be assigned to each receptacle. This is based on the assumption that each receptacle will be used to power a variety of small appliances and devices. To determine the maximum number of receptacles on a 20 amps 120 volt circuit, divide the total circuit capacity of 2400 volt amps by 180 volt amps per receptacle. This gives approximately 13 receptacles. However, as with lighting circuits, it is recommended to limit the load to 80% of the circuit's capacity. This means that the maximum number of receptacles on a 20 amps 120 volt circuit should not exceed 10 receptacles. It is also important to consider the type of load that will be connected to the receptacles. If the receptacles will be used to power high wattage appliances such as heaters or air conditioners, the number of receptacles should be reduced accordingly. In addition to the NEC guidelines, local codes and regulations may also impact the number of lamp holders and receptacles that can be installed on a circuit. Some jurisdictions may have more stringent requirements than the NEC, so it is important to consult with a qualified electrician or local electrical inspector to ensure compliance with all applicable codes and regulations. Firstly, ensure that the circuit is properly protected by a 20 amp circuit breaker. Secondly, use appropriately sized wiring for the circuit. For a 20 amp circuit, a minimum of 12 American wire gauge or AUG copper wire is typically required. Thirdly, properly ground all electrical devices and equipment. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock and fire hazards. The NEC provides detailed requirements for grounding in Article 250. Fourthly, use listed and labeled electrical devices and equipment. Listed and labeled products have been tested and certified by a recognized testing laboratory to meet safety standards. Fifthly, follow all manufacturer's instructions for installation and use of electrical devices and equipment. Sixthly, do not overload circuits. Overloading a circuit can cause overheating, electrical fires, and other hazards. Seventhly, inspect electrical systems regularly for signs of damage or wear. Damaged wiring, loose connections, and other problems can create electrical hazards. Eighthly, have electrical work performed by a qualified electrician. Electrical work can be dangerous, so it is important to hire a qualified professional to ensure that the work is done safely and correctly. Ninthly, use ground fault circuit interrupters, or GFCIs, in areas where there is a risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect ground faults and quickly shut off power to prevent electric shock. Tenthly, use arc fault circuit interrupters, or ASIs, to protect against arc faults, which can cause electrical fires. ASIs are designed to detect arc faults and quickly shut off power to prevent fires. When working with electrical systems, always follow these basic safety precautions to protect yourself and others from electrical hazards. Remember that electricity can be dangerous, so it is important to take all necessary precautions to prevent accidents and injuries. The NEC serves as a comprehensive guide for safe electrical installations and practices, promoting safety and standardization across the electrical industry. To understand the application of these concepts in real-world scenarios, consider a typical residential setting. In a living room, for instance, you might have several lamps, a television, and various electronic devices plugged into receptacles. Calculating the total load from these devices is crucial to ensure that the circuit is not overloaded. If each lamp uses a 60-watt bulb, and there are 5 lamps, the total lighting load is 300 watts. If the television draws 150 watts and other devices collectively draw another 100 watts, the total load in the circuit is 550 watts. This load should be well within the 80% limit of a 20 amp circuit, which is 1920 watts. However, if you add a space heater that draws 1500 watts, the total load becomes 2050 watts, exceeding the recommended limit and potentially causing the circuit breaker to trip or creating a fire hazard. In a kitchen setting, the demands on electrical circuits are often higher due to the use of appliances such as refrigerators, microwave ovens, and toasters. A refrigerator typically draws around 150 to 200 watts, while a microwave oven can draw 600 to 1200 watts. A toaster might draw 800 to 1200 watts as well. If all these appliances are on the same circuit, the total load could easily exceed the 80% limit of a 20 amp circuit. This is why kitchens often require multiple dedicated circuits to handle the high electrical demands. For example, a refrigerator might have its own dedicated 20 amp circuit to ensure that it always has sufficient power and to prevent it from tripping the breaker when other appliances are used. Similarly, a microwave oven or a toaster might require a dedicated circuit to handle their high wattage draw. In commercial settings, the electrical demands are even higher than in residential settings. Offices, retail stores, and factories often require a large number of lighting fixtures, computers, and other electrical equipment. In these settings, it is crucial to carefully calculate the load on each circuit and to install an adequate number of circuits to handle the total electrical demand. For example, an office space might have hundreds of fluorescent lights, each drawing around 40 watts. If these lights are all on the same circuit, the total load could easily exceed the capacity of the circuit. To prevent overloading, the light should be divided among multiple circuits, each with its own circuit breaker. Similarly, a retail store might have a large number of cash registers, computers, and other electrical equipment. These devices should be divided among multiple circuits to ensure that the total load on each circuit does not exceed the recommended limit. In industrial settings, the electrical demands are often even higher due to the use of heavy machinery such as motors, pumps, and compressors. These machines can draw a significant amount of power, and it is crucial to carefully calculate the load on each circuit to ensure that it can handle the demand. In some cases, dedicated circuits with high amperage ratings may be required to power these machines. For example, a large motor might require a 50 amps or 100 amps circuit to provide sufficient power. It is also important to consider the voltage requirements of different electrical devices and equipment. In North America, most residential and commercial buildings use 120 volts for lighting in small appliances and 240 volts for larger appliances such as ovens and air conditioners. In other parts of the world, different voltage standards may be used. For example, in Europe, the standard voltage is 230 volts. When installing electrical equipment, it is crucial to ensure that it is compatible with the voltage of the electrical system. Using equipment that is not designed for the correct voltage can damage the equipment and create a fire hazard. Additionally, it is important to use the correct type of receptacle for the voltage and amperage of the electrical device. Different types of receptacles are designed for different voltages and amperages, and using the wrong type of receptacle can be dangerous. For example, using a 15 amps receptacle for a 20 amps device can cause the receptacle to overheat and create a fire hazard. Understanding these principles and applying them correctly is essential for ensuring electrical safety and compliance with the NEC. The NEC is regularly updated to reflect changes in technology and best practices, so staying current with the latest edition is vital for all electrical professionals. By following the NEC guidelines and consulting with qualified electricians, you can create safe and efficient electrical systems that meet the needs of your home, business, or industrial facility. Remember that electrical work can be dangerous, and it is always best to hire a qualified professional to perform any electrical installations or repairs. Working with electricity requires specialized knowledge and skills, and attempting to do it yourself can put you and others at risk.